Hello everyone, welcome to my channel Similarity. In this video, we will see how we can create a vellum inflation effect. Okay, so this effect basically looks like this here. Okay, so before I begin, let me give you a overall tour of this whole thing. So first, I created this toy geometry here, and then I remeshed it. Okay, so that I can have one single mesh here, and then I created a mask here. Let me show you the mask. You can see I've created this mask here. Okay, then using this mask I have controlled all the constraint we are uh, using in the vellum. Okay, so this is how this whole thing works, and now let's just get right into it and create this from the scratch. Okay, so the first thing we need here is a geometry node, and now let's create a toy here. Also you can see the toy is below the grid here, so let's use a match size node, and we can now place it just above the grid. Okay, and now the next thing we need to do is to convert this into VDB, because you can see basically this geometry is made up of multiple meshes here. Basically these these top meshes are just intersecting here. Okay, this is not the part of the original mesh. So what we can do, we can convert this into a VDB from polygons. I can set this value to 0.01. Okay, now we can convert this into a polygons here. Okay, so now our VDB is converted into polygon, and this is a one single mesh. Also, if you want, you can also use a remesh here, so that you can have a better topology. Okay, I think this one looks good. Okay, so now the next thing we have to do is to create a mask here. But before I begin, let me tell you, I am not going to create a very complex looking mask, or I'm not going to create a very complex setup here for the mask generation, because this is not a tutorial about mask generation in Houdini. It's about vellum inflation. So if you want, you can definitely create some complex looking mask using Vex or Wops or Mops, whatever you like. Okay. For this one, I'm going to create a very simple setup for the mask generation. So for that, first thing I need is a attribute paint here. So we can paint here, I think. Okay, now I'm going to expand this. For that, I will use a solver. And inside the solver, we can create a attribute transfer here. And set this to mask. And I think 10 sample count is enough. Also, we don't need this distance threshold, because we are working on the same geometry here. Now let's check if this is working or not. So you can see this is working perfectly fine here. But the problem here is our mask is not, it's getting blurred actually. So, for each time step. So what we can do, we can create a attribute wrangle here. And we can multiply our mask. First, let me set this to here. Mask by some value for each time step. Okay. And now let's check if this is working fine or not. Okay, this is working great. But there's one problem. You can see this here. Basically, this is this is not that our mask is getting value 0 here. It's just that the value is very high here, very large values are here. That's we are seeing this kind of effect. You can also check here if I show you. You can see the values are very large, right? 40841735. So what we can do, we can write if at the rate mass equals 1, sorry, not 1, greater than 1. Okay, we can write at the rate mass equals 1. Basically we claimed the value of mass here. Okay, now you can see the error is gone and we have a expanding mask here. Okay, so this is our mask here, and the next thing we need to do, we can also use the attribute remap also. I don't know, but I think we might need it in the Vellum solver, so why not create it right now? Sorry, attribute remap, and we can put the mask here. So basically this node we can use to remap our mask values. So right now I am not changing any values here. It's starting from 0 to 1, and also the output also is 0 to 1. We might need it in the Vellum solver, so I am creating it right now. Okay, so we can use a null here, and we can use out mask, right? Okay, so now next thing we need to do is to create our Vellum setup here. So we will be using the Vellum configure balloon here, because basically this gives us two nodes, one for the cloth and one for the pressure. Okay, and now we can put our Vellum solver here. Okay, also let's create the ground here and let's check if this is working or not. Okay, this is working fine here. Okay, so now the next thing we need to do, basically first I am trying to create a deflated mesh here. Okay, because if you remember from the original example, you can see the inflation begins from the frame number 30 here. Okay, before that I want the mesh to be deflated completely. Okay, so for that what we can do, let's check these values here. Okay, I think the stretch value is too low, so we can do it like this. Also the damping ratio we can control here. Let's put to 0.1. So because we don't want any kind of movement, like obviously some movements are good, but we don't want like too much jiggling here. Also we can set this to very low value so that we can have more wrinkles in the deflate state. Also we can set this to 0.1, right? And I think pressure is good. Okay. Okay, so but before I begin creating the deflated state of the mesh, let me tell you one thing about an attribute called pressure scale. Okay, so there's an attribute in Houdini called pressure scale, which basically controls controls for which point the pressure constraint will work. Okay, so if the attribute value is 1, the pressure constraint will work on those point, and if the the pressure scale attribute value is 0, the pressure constraint won't work on those points. Or you can, in simple language, if the attribute value is 1, the pressure will work for those point. If the attribute value is 0, the pressure won't work for this point. And if the value is somewhere in between, the pressure values will also be somewhere in between for those points. Okay, you can also check the documentation. Let me show you here. I think pressure, Houdini pressure scale. Okay, here. So you can see this is the attribute I'm talking about, pressure scale. Okay, pressure scale point attribute can be used to scale the effect of the pressure constraint on per point basis. Okay, So in simple language, this means we can control for which point the pressure will work, and for which point the pressure won't work. Okay. So this is what we're going to control through this attribute. Also, you can see the side effects also uses this inflation example here, but I think this example has one issue. Let me show you. You can see like we are not getting the original shape here. See, the original shape looks something like this, but after the inflation, you can see it's still like what you say, like it's inflated, but it's like what to say, like it's still dangling, and the mouth is not in the correct position, something like that. So we want to control that also, and that we are going to do in our example. Okay. Okay, so next thing we need to do is to go inside the solver. So basically this area is called a dive target. Okay, and we can create a geometry wrangle here, and let me set the first input to SOP, and we are going to use our mask. Okay, so we are going to use the mask to control on which point the pressure will be applied, and also for that we are going to use the pressure scale attribute. So first, like PS pressure scale, 0.0 mask @etnum. Okay, and what we can do, we can create the pressure scale here. Pressure scale equals PS. Okay. Okay, I think this one will work. Let's check if this is working or not. So for all those points for which the pressure scale attribute is value 0, there will be no pressure at all. And for the point which has the pressure scale value of 1, we'll have the maximum pressure that we have set here. Okay. Now let's check if how this is working. So you can see something is happening here. Okay, but this is not the thing we want. So I think what we can do, first let me set the pressure to something like this. Let's see what will happen to very high values. Okay, and you can see there's something very weird is happening. Okay, so the first thing we need to do, we need to apply the pressure after the mesh is fully deflated. So we can go inside the solver. We can create a switch node here. We can put this here, and also what we can do, okay, so this is our input 1. Okay, the geometry goes into the input 1. So I think, yeah, this is our input 1, and we can put a null here. And we can write $ff after 30. Okay, so what would happen, this is the input 1, this is the 0. Okay, so as soon as our after frame number 30, the switch node switches to this input 1 here. Okay, you can also check here. Let's see, you can see before the frame number 30 we are getting the mesh here. Okay, and then after the frame 30, so I think we need to reverse this, right? So you can see after the frame number 30, we are working on the mesh, and before that there will be null object. Okay, so let's check the mask attribute. Yeah, you can see, so the mask began expanding after the frame number 30 here. So let me do this here, and now let's check. So what will happen right now, after the frame number 30, the pressure scale attribute will start working. Okay, so I think we have solved one of the problem. So now up till frame number 30 we have a very completely deflated mesh, and then after that the pressure scale is start to work. But there's one problem, this. So why this is happening? Well, this is the reason for that, because you can see inside the pressure here, we have this rest length scale. Basically, this controls the volume of the object here. Okay, the larger the value, the greater the volume of the object. So when the pressure scale value turns to 1 here, for the mask region, there's sudden increase in the rest length of the, or you can say the Houdini, the Vellum Houdini will try to suddenly increase the volume of the object here. Okay, there's sudden increase in the volume. See, that's why we are seeing this effect here. Okay, this pulling effect here. So what we need to do, we need to basically control this rest length as well. See, we want to increase the rest length gradually from 0 to 1. Then we don't want to increase like suddenly goes from 0 to 1 here. We want a gradual increase here. So what we can do basically, can create a vellum constraint properties here, and where this rest length scale. Okay, let me set this to manual here, 0. We're gonna put a keyframe here, and then I think for frame number 240, I think this works. We can put 1 here, or I think 1.1, a bit more increase in the volume from the original volume. Okay, so this is here, and now let's just set this to auto update, and let's see if this is working or not. Okay, something weird happened here. And what is that? Okay, wow, yeah, one thing here. You can see right now we are changing the rest length for the whole object, for the cloth, for the pressure as well. So we need to define a group. Okay, but you can see we only have this bend and stretch constraint here, and these are coming from the cloth node here. So we want this for the pressure constraint. So for that we need to create a group here, pressure stretch. Okay, because this is the value we want to control. Also we can change the damping here as well, and you can see. And now let's check. And you can see here we are getting something that we like. Okay, but still there's some problem here. Our cloth is not expanding like, okay, like to the original mesh. So what we can do here, let's check. Okay, I think the issue will be solved if we increase the bend strength here. Okay, bend value here, because let me show you in the Photoshop what this bendiness mean. So let's say we have point here, another point here, and another point here. Okay, and this is the constraint between them. Okay, so these are the points, these are the edges, whatever you like. So basically the bend strength or the bend value for the constraint tells us how much one point can rotate around another point. Okay, because this controls this rotation here. Okay, for each of this point, how much this point can rotate around this point, how much this point can rotate around this point. Okay, so if the bend strength, the bend stretch value is very high, we get a very like this kind of shape. Okay, so we don't get that many wrinkles or whatever you like to say here. But if the bend stretch value is very low, we get something like this here, because the point can rotate around each other very easily. Okay, so that's what bend stretch means. Let's control this value as well. So we can go inside here, and first let's call this pressure rest length, and we can vellum constraint properties here, and here we are going to control the bend value here, and we can control the stiffness of the bend value, right? Also, let's check what's the original bend value here for the cloth. Here. Okay, so you can see the original value is 0.0001, right? Okay, and the stretch also is 1e plus 10. Okay, so basically 10 zeros after 1. Okay, so I think we can control both of these values inside the solver as well. So let's set this to 0.0001. Okay, so we can set the same value here as well. And now we can use the vex input. We can use the mask that we have created. Okay, so we can write float mask equals point from the input, I think third one, right? 1 to 3. Okay, so we can write here 2 mask at the rate ptnum, and we can set our stiffness. Basically we can multiply the stiffness, okay, with our mask value, and let's check if this works or not. Okay, this has some effect, but I think we can control it a bit more. So we can fit this value, fit 0 1 between the value of 1 to 1 2 3 4 5 6 7 8 9 10. Okay, because we want a very high stiffness value for the bend. Yeah, I think this is working right now. Okay, we are getting somewhere. Also, one more thing we can control here. We don't want to, start acting it from the frame number 1 here. We can also set this. Well, I'm doing this because see, I don't want to, get the whole cloth getting high bend value from the beginning. Okay, we want the, what to say, like the bendiness, begins somewhat later in the frame. Okay, so because that looks more good and believable. Okay, one more thing, we can also control the stretch value as well. So just let me just copy it, and this is the bend stretch we are controlling here, and this is the stretch stress. Okay, and we can set this to stretch here instead of bend. And the stretch value, let's check what that. The stretch value is 1e plus 10. Okay, so let's set this here, and now let's see how this works. Okay, I think we have achieved most of the thing that we want. Well, if you see the example that the side effects gave here, basically what they are doing, they are, the rest length they are setting for this is very high. So we can also try that. What we can do here, we can go to 240, and we can set the rest length to something like 2 here. Let's see what will happen. Okay. Okay, and I think the bend value will also be high here. Let's set this to 1. I think that will be better. See, because what I'm trying to do, I'm trying to get the original shape as much as I can. Okay, I don't want some inflated looking toy here. I want to get the original shape, and I want to retain the original shape as much as I can. So I think we have created up till what the side effect example showed here. Okay, now we if you want to control this more, so basically to get the the look of the original shape as much as we can basically use one more thing here. Let me show you. We can create another vellum constraint here, and we can plug it here, and we are going to basically use the pin to target constraint. Okay, and we can set this to soft, this also soft, and we can set its value I think to 1, or I think we can also set this to 0, right? Also let's set a group here as well, we might need it in the solver, so we can call it pin stretch, right? Now let's check also, let me set the damping value to 0.1 as well. Now let's check if something is happening or not. Okay, okay, there's this issue here, we can remove that later. Okay, I think this is working perfectly fine here. Okay, so now what we can do here, let's first set this to pin to target. Okay, so we can go inside here, and we can create another vellum. Oh sorry, we can also just copy it here. Okay, and we can call it pin stretch, and we can set this value to 1 I think, and we can use the pin group. Okay, and now we are going to basically control the stiffness of the pin using the mask here, right? So all we need to do is to set this to from 0 to 2. I think this will work. Let's see. Yeah, you can see now we are getting more of the original shape here, right? Yeah, you can see. Now for this issue we have here, also one more thing before removing the issue. There's one problem you can see here. You can see this is this portion is inflating very like earlier. Okay, we don't want to inflate it like suddenly here. So what we can do, we can go inside, and for the pin stretch we can set it to begin this after frame number 60, or I think 50. Let's see, let's check what worked fine here. Yeah, I think this looks more better. See now, now it's all about playing with the values right now. Okay, the core logic we have already created. Now it's all about playing with the values, to see what works best. So we can set this to 60, I think. Also, I think we can also use the post process here. You can do the subdivision. Now let's say, okay, let me just, try multiple values here, and I will cut the video from here because I'm going to try what values, works best, because right now everything is created and all we need to do is to, just get the value that, looks good for this inflation effect. Okay, so you can see here I have played with multiple values and I've changed some of the values here. Basically, I changed the stiffness frame number to start the pin stiffness after frame number 40 here, and also uh, for this one, for the stiffness, I have changed this to like 1 then 10 zeros here, and one more thing I believe I changed here. Let me show you. Okay, here in the Vellum post process, I've applied a spatial blur here as well. So now you can see, now if I, try this, I think I've also inflate, cache this. So let's check the cached version here. And you can see this is working perfectly fine now. Okay. So I will provide you this file and you can try your values as well and try multiple setups here. And okay, so this is it for this video. And also if you want, you can try to create different effects with this if you want. I mean this is a very cool thing to inflate object. Okay, so this is it for this video, and if you like this video, please hit the like button and please do subscribe my channel. I really find it very motivating when you do that. It gives me motivation to create new videos. So thank you for watching this video, and thank you, bye.